Now that we have discussed how the WWC assesses compositional change in individual level RCTs, we now will shift to a discussion of assessing compositional change in cluster level RCTs. The WWC uses a different process for assessing compositional change in cluster RCTs, given the different sources of potential bias in cluster-level assignment designs. The risk of bias in cluster RCTs can arise from two sources. First, if there are any changes in the sample of clusters. In other words, was there a change in the unit of assignment, or the clusters that were assigned to conditions? The second source of potential bias in cluster RCTs is whether there are any changes in individuals within clusters. In other words, was there a change in the unit of measurement, or those individuals within clusters? The WWC uses three terms to describe the individual sample members who might contribute to compositional changes within clusters. First are stayers. Stayers are individuals who were in clusters at the time of random assignment and who stay in those clusters until the end of the study and contribute outcome data to the analytic sample. Next are joiners. Joiners are individuals who are not in clusters at the time of random assignment, but instead they join or enter the sample later. As we'll discuss in greater detail, when joiners contribute outcome data to the analytic sample, they can contribute to compositional changes. And finally, there are leavers. Leavers are individuals who were in clusters at the time of random assignment, but they leave those clusters after random assignment, meaning they often do not contribute outcome data to the analytic sample. These leavers, who leave clusters after random assignment, may contribute to individual-level attrition within a cluster-level RCT. Let's look at an example to illustrate these terms. Consider a study that randomly assigned schools to an intervention or comparison group. In this example, schools were randomly assigned so that the intervention and comparison conditions each include two schools. The schools are the clusters, represented by the groups of students, and the students within each school are the individuals. The researchers obtained school rosters, that is, lists of students who were expected to attend each school at the time of random assignment. The stayers are students who were listed on the original school rosters. Among the stayers are students present when the study collected outcome data and were included in the analytic sample. The images for the individual students are different colors, representing different baseline characteristics such as pre-intervention achievement levels. The students on rosters at the time of random assignment, on the left, are similar across the intervention and comparison groups. However, the students who the authors actually analyzed outcome data for within each condition, shown on the right, are not similar. The students in the intervention group schools changed because of attrition and joiners. Those not on the initial rosters on the left, but present in the analytic sample on the right, are joiners. Joiners might include students who enrolled on the first day of school or who transferred at some point during the school year. The purple and blue students in the intervention group left the study, and they are considered leavers. These students were replaced in the analytic sample by new red students. These new red students are joiners. In this example, there are only joiners present in the intervention group. But it is important to remember that in any cluster RCT, it is possible for joiners to be present in the intervention group, the comparison group, or both. The green and blue students in School D in the comparison group also left the study. The other green and red students, who were originally in the intervention, remained in the study, so these are stayers. All students in the comparison condition are also stayers. Although the individuals in the intervention and comparison groups were compositionally similar at the time of random assignment, this is not the case for the analytic samples used for impact analyses. For example, imagine that the students shown in red in this illustration are among the highest scoring students, so that on average they outperform the students shown in purple, blue, and green. There are equal numbers of red individuals in the intervention and comparison groups at random assignment, but at follow-up, the study experiences some individual level attrition and joiners enter the clusters. Now, because there are more red individuals in the intervention group than in the comparison group, the intervention group has higher average test scores at follow-up than the comparison group. As a result, even if the intervention has no effect, it may appear to have an impact due to compositional changes. Just like attrition in individual level RCTs, compositional changes in cluster RCTs can result in biased impact estimates if something other than the intervention is causing the difference between the groups in the study. The WWC assesses three types of compositional change in cluster RCTs. This includes change in the sample of clusters, which refers to cluster-level attrition. In other words, did the study lose one or more clusters after random assignment was completed? The WWC also assesses any changes in individuals within clusters. This involves assessing joiners, or the individuals who enter clusters after random assignment, and it also involves assessing individual-level attrition, which refers to the loss of individuals who were present in clusters at the time of assignment, or the loss of individuals who are present in clusters at follow-up but have missing data. In order for findings from a cluster RCT to receive the highest research rating of meets WWC standards without reservations, those findings must have a low risk of bias due to compositional change. Low risk of bias due to compositional change is defined as having low cluster-level attrition, limited risk of bias due to joiners, and low individual-level attrition. This figure shows the steps involved in reviewing compositional change in cluster RCTs. Cluster QEDs and compromised cluster RCTs should skip these steps on compositional change and should proceed to the fourth step in the review process, assessing baseline equivalence, which is covered in the next training module in this series. As shown in this figure, in order to receive the highest research rating of meets WWC standards without reservations, a cluster RCT must have low cluster-level attrition, must limit risk of bias due to joiners, and must have low individual-level attrition. Passing all three of the steps shown in this figure, so steps 3A, 3B, and 3C, means that the cluster RCT has a low risk of bias due to compositional change. Before discussing each of these three steps in greater detail, it is important to highlight that for any RCTs that need to satisfy the baseline equivalence standard, the choice of attrition boundaries and the presence of high-risk joiners in the analytic sample can affect the available options for satisfying the baseline equivalence standard, which is discussed in the next training module in this series. So, it is important to remember that when reviewing cluster RCTs, the presence of leavers will affect how reviewers assess attrition in the study, which then has implications for how a review proceeds through each step in the review pathway. And the presence of joiners will affect how reviewers assess cluster representativeness and baseline equivalence in the study. Step 3A in the study review process involves assessing whether the findings from a cluster RCT have low cluster-level attrition. Recall that cluster RCTs must have low cluster-level attrition in order to be eligible to receive the highest possible research rating of meets WWC standards without reservations. Cluster attrition occurs when no individuals from a cluster contribute outcome data to the analytic sample. For example, if a research study randomly assigned 10 schools to the intervention and comparison group, but one of those schools dropped out of the study and the researchers did not collect outcome data from that school, then the one lost school would count as cluster-level attrition. So in this example, the study would have a 10% overall cluster-level attrition rate, because one of the 10 originally assigned clusters was lost to follow-up. When assessing cluster-level attrition, reviewers used the same attrition standard that was described previously for individual-level RCTs, but the standard is instead applied to clusters. This means that review teams again will choose an appropriate attrition boundary, either cautious or optimistic, and then will use the same tables for determining whether there is low or high attrition under that boundary. It is important to note that the boundary used in this step, whether it be the cautious or optimistic boundary, can be different from the boundary used to assess individual-level attrition within clusters. Let's walk through an example to demonstrate how to calculate cluster-level attrition in a cluster RCT. A study randomly assigned 10 schools to a reading intervention and 10 schools to the comparison condition. There were 50 second graders in each school at the time of random assignment. The study team collected outcome data from only these students. All of the intervention schools contributed outcome data to the analysis, but one of the comparison group schools refused to allow the researchers to collect outcome data. In total, the researchers collected post-test data from 500 intervention group students and 375 comparison group students. The review team leadership determined that an optimistic attrition boundary was appropriate for this study review because loss of clusters is not expected to be related to intervention status. So, what is the overall attrition rate for the clusters? What is the differential attrition rate for the clusters? And does this example have low or high cluster level attrition? Let's first organize the numbers in the example. For the intervention group, we know that there are 10 clusters, or schools, assigned to the intervention group, and the researchers collected post-test data from all 10 of those schools. For the comparison group, we know that 10 schools were assigned to this condition, but the researchers were only able to collect post-test data from 9 of those 10 schools. The total cluster sample size at the time of the assignment is 20, and the total cluster sample size contributing outcome data is 19. To calculate overall cluster level attrition, we will need two quantities: the total number of clusters in the randomly assigned sample and the total number of clusters contributing outcome data. We then take the difference of these two totals to calculate the total number of clusters without observed data. So, looking at our example, we know we started with 20 randomly assigned clusters. The researchers observed outcome data for 19 of those clusters. The loss of one school or cluster from the 20 randomly assigned clusters represents cluster level attrition. So, 5% is our overall cluster level attrition rate, which is equal to 1 out of 20. Then, to calculate differential cluster level attrition, we need to conduct calculations for each group. For the intervention group, we started with 10 randomly assigned schools. The researchers observed data for all 10 of those schools, so there was 0% cluster level attrition in the intervention group. For the comparison group, one of the 10 randomly assigned schools lack outcome data. This results in a 10% cluster level attrition rate for the comparison group. So, to calculate differential cluster level attrition, we take the absolute value of the difference between the two cluster level attrition rates. We get 10 percentage points as our differential cluster level attrition rate. We can then take these calculations and compare them against the table on pages 150-151 in the handbook to assess whether this combination of overall and differential attrition represents high or low cluster level attrition under the optimistic boundary. Again, recall that WWC review teams are responsible for determining the appropriate attrition boundary and they will document this decision in the study review guide. And when determining which attrition boundary to use, review teams will consider carefully the likelihood that the intervention may affect attrition. If the review team cannot make a defensible decision between the two boundaries, they will default to the cautious boundary and document this choice as well. You'll see that given an overall attrition rate of 5%, the maximum allowable differential attrition rate is 6.1 percentage points under the cautious boundary and 10.5 percentage points under the optimistic boundary. Recall that the differential attrition rate from our example was 10, which is lower than the 10.5 optimistic maximum, so this level of attrition would be low under the optimistic boundary. However, had the review of the study taken place under the cautious boundary assumption, this would have been considered high cluster level attrition. We now have reviewed step 3A in the process for assessing compositional change in cluster level RCTs. For cluster RCTs that have high cluster level attrition, the review will proceed to step 4 in the review process, which is described in the next module in this training series. But for cluster RCTs that have low cluster level attrition, the review then will proceed to step 3B, which will evaluate whether the study findings limit the risk of bias due to joiners. At this step in the study review process, reviewers will assess the risk of bias due to joiners. Recall that joiners are individuals who enter clusters after the results of random assignment are known to anyone who could plausibly influence individuals' placement into clusters, including family members, students, teachers, principals, or other school staff. The WWC is concerned with joiners in cluster RCTs because they change the composition of the study sample. And because of this, joiners introduced uncertainty about the causes of an intervention effect. For example, consider an RCT that randomly assigns classrooms to receive an experimental science curriculum or business as usual instruction in the summer, before student classroom rosters are set. School staff might assume that this curriculum is better suited to those students who are high-performing in STEM classes, and because of this, they purposefully place those students into the intervention classrooms. This differential placement could bias intervention effect estimates for student outcomes, since students in the intervention classrooms might outperform those in the comparison classrooms solely because of pre-existing differences between students, rather than improvements caused by the intervention. But the risk of bias due to joiners might be low in other cases. For instance, joiners in RCTs that randomly assign schools to conditions often pose a low risk of bias, because switching schools is usually much more difficult than switching classrooms or teachers within a school. Those individuals who influence students' school placements, such as family members or even the students themselves, may be unaware of the intervention. Even if they are aware of the intervention, they may decide that switching schools for the intervention may require too much effort or disruption. So in some scenarios like this, joiners pose a low risk of bias. When the risk of bias due to joiners is low, the inclusion or exclusion of joiners in the analytic sample will not affect the WWC research ratings for study findings. However, when the risk of bias due to joiners is high, studies must limit that risk by excluding joiners from the analytic sample in order to be eligible to receive the highest research rating. So how do reviewers assess the risk of bias due to joiners? Well, reviewers will assess the risk of bias due to joiners based on 3 factors: the unit of assignment, the unit of measurement, and the potential for the intervention to affect joining. This figure shows the process that reviewers use to assess the risk bias due to joiners and shows the 3 factors that are considered. First is the unit of assignment. Second, the unit of measurement. And finally, the intervention's potential to affect joining. We now will discuss each of these in detail. The first factor to consider when judging the risk of bias due to joiners in cluster RCTs is the study's unit of assignment. The WWC generally considers the risk of bias to be low for cluster RCTs where the unit of assignment is at the school level or larger, such as the district or state level. Conversely, the WWC considers the risk of bias due to joiners to be high when the unit of assignment is smaller than a school. For example, if the study assigned teachers or classrooms to conditions. As described earlier, switching teachers or classrooms is typically easier than switching schools, and it is easier for school staff to assign students to teachers or classrooms based on knowledge of the intervention. The WWC assesses the unit of assignment because it determines who could plausibly influence enrollment decisions. And again, more people may be able to influence within school placements than between school placements. The second factor that the WWC considers when judging the risk of bias due to joiners in cluster RCTs is the unit of measurement. The WWC considers the risk of bias due to joiners to be high when the unit of measurement is not students, such as for analysis of teacher outcomes in school-level RCTs. This is because, compared with students and their family members, teachers may have greater knowledge of educational interventions offered at a school and may select a school based on factors such as the school's participation in an intervention. At this step, Step 3b, the WWC only assesses joiners for the unit of measurement. The WWC does not consider individuals as joiners if they're not the unit of measurement. The third factor that the WWC considers when judging the risk of bias due to joiners in cluster RCTs is the intervention's potential to affect joining. The WWC generally considers school-level RCTs of student outcomes to pose a low risk of bias due to joiners, unless the intervention has a high potential to affect joining. To have a high potential to affect joining, an intervention must have both high intervention visibility and high enrollment flexibility. Interventions with low visibility or limited enrollment flexibility have a low potential to affect joining. So what do we mean by intervention visibility? Intervention visibility refers to whether those with the ability to manipulate enrollment are aware of the intervention, and if that knowledge could plausibly influence placement decisions. This means that intervention visibility depends on whether the individuals who could manipulate enrollment are both aware of the contrast in educational services provided across groups and they view those differences as a key factor in enrollment decisions. This is important because even highly publicized programs and interventions could appear similar across conditions. Or some interventions might be visible to some individuals, such as teachers, but may not be visible to those individuals, like parents, who might plausibly affect students' enrollment decisions. Some types of interventions that may be highly visible include magnet programs, after-school programs, charter schools, or schools with appealing incentives for enrollment, such as free laptops or tablets for students who enroll. When assessing the enrollment flexibility of an intervention, the WWC assesses whether it is relatively easy to join a study cluster after random assignment. One consideration for determining enrollment flexibility are grade-level transitions with regular cross-school changes. Many school systems have grade-level transitions with cross-school changes, such as from grade 8 in middle school to grade 9 in high school, which increases enrollment flexibility. For instance, a rising grade 9 student may partly decide their high school choice based on advanced placement opportunities at the school. Another consideration is for after-school or other supplemental programs that may draw students enrolled in other schools, which would increase enrollment flexibility. A third consideration is for longer versus shorter time spans between random assignment and follow-up data collection. Joining schools may be easier with longer time spans between random assignment and follow-up data collection, especially for outcomes collected 2 or more years after random assignment. The fourth and final consideration is related to differences for post-secondary students and adult learners versus K-12 students. Enrollment flexibility may be greater for post-secondary students and adult learners compared with K-12 students, since older students may exercise greater control over their educational experiences. This is particularly relevant if institutions or programs were randomly assigned to conditions before individuals in the analytic sample enrolled into them. We have now reviewed Step 3B in the process for assessing compositional change in cluster-level RCTs. For cluster RCTs that do not limit the risk of bias due to joiners, the review will proceed to Step 3D in the review process, which is described later in this module. But for cluster RCTs that have limited the risk of bias due to joiners, the review will then process to Step 3C, which will evaluate whether the study findings have low individual level attrition. It is important to note here that the risk of bias due to leavers, which was assessed previously in Step 3B, informs the review team's choice of the cautious versus optimistic boundary for assessing individual level attrition. This is consequential because if the risk of bias due to leavers is high, review team leadership should always use the cautious boundary for assessing individual level attrition. But if the risk of bias due to leavers is low, the optimistic boundary is usually appropriate for assessing individual level attrition. Thus, the findings from Step 3B in this process determine how the reviewer proceeds through the remaining steps in the review process for cluster RCTs. At Step 3C in the review process, reviewers will assess individual level attrition in cluster RCTs. Individual level attrition in cluster RCTs is defined as individuals who leave clusters after random assignment, called leavers, and individuals who are present in the clusters at follow-up but have missing data. Both of these types of individual level attrition can pose a risk of bias. As we have already discussed, leavers can pose a risk of bias if the intervention makes some individuals more or less likely to leave the clusters. The intervention could impose a burden that might increase leaving. For example, imagine a classroom-level RCT where intervention group students will receive a challenging science curriculum. This challenging curriculum might incentivize lower-performing students to move to other classrooms. But the intervention also could provide additional benefits or supports that might make individuals more likely to stay, thereby decreasing leaving. Whatever the case, interventions that affect leaving in either direction could pose a risk of bias for some types of cluster RCTs. Individuals with missing outcome data who are present in clusters at follow-up also could pose a risk of bias because aspects of the data collection process could differ across conditions. For instance, researchers might obtain higher student consent rates in intervention schools than comparison schools. Other common missing data issues might include differential teacher compliance, student absences, sampling design, or individual-level recruitment procedures. All of these issues could pose a risk of bias if they differ across study conditions. WWC reviewers will evaluate individual-level attrition in cluster RCTs by comparing the analytic sample size with a reference sample size, such as the number of students present in the clusters at the time of random assignment. Note that this reference sample consideration is what differentiates how the WWC calculates attrition in individual-level RCTs versus cluster RCTs. The reason that the WWC uses a reference sample for the attrition calculations for cluster RCTs in order to account for joiners and attriting clusters. What counts as an allowable reference sample for this purpose will depend on the WWC's determination of the risk of bias due to leavers. But overall, it is important to note that the participants in the reference sample does not necessarily have to overlap with the participants in the analytic sample used for impact estimation. Importantly, note that the risk of bias due to leavers can differ from the risk of bias due to joiners, depending on the nature of the intervention and review team leadership's judgments. These judgments regarding the risk of bias from various types of compositional change are documented in the study review. Importantly, note that the choice of boundary for assessing individual-level attrition is separate from the choice of the boundary used to assess cluster-level attrition in Step 3A. In other words, Even when the optimistic boundary is appropriate for assessing individual-level attrition, the cautious boundary could remain appropriate for assessing cluster-level attrition. The initial categorization into high versus low risk of bias due to leavers focuses only on leavers, not other types of individual-level attrition, such as individuals who remain in the cluster but have missing outcome data. For RCTs with a low risk of bias due to leavers, there are more options for allowable reference samples. For RCTs with a high risk of bias due to leavers, the WWC will assess individual-level attrition using an early reference sample. Findings from studies with a high risk of bias due to leavers can still receive the highest research rating of meets WWC standards without reservations, but findings from these studies need to meet more stringent individual-level attrition requirements than RCTs with a low risk of bias due to leavers. This image shows how WWC reviewers assess the risk of bias due to leavers in cluster randomized controlled trials. In general, units of assignments smaller than a school and units of measurement other than students are more likely to pose a high risk of bias due to leavers. In contrast, school-level RCTs of student outcomes often will have a low risk of bias due to leavers. One important exception for school-level RCTs of student outcomes, however, is interventions with a high potential to affect leaving. Having a high potential to affect leaving means that the intervention could plausibly influence student mobility, and enrollment flexibility is high. If both of those conditions are met, review team leadership should clarify the risk of bias due to leavers as high and should use the cautious attrition boundary. When assessing the risk of bias due to leavers, reviewers first will assess the intervention focus and whether the intervention could plausibly influence student mobility. At this step in the review process, an important consideration is whether the intervention provides benefits and supports that may induce students to stay, or conversely, whether the intervention imposes a significant burden that may motivate students to leave. The other key consideration when assessing the risk of bias due to leavers is enrollment flexibility, namely, is it easy to leave a study cluster after random assignment? Again, reviewers will consider the same factors related to enrollment flexibility that were used in the previous step when assessing joiners. That is, considering whether there are grade-level transitions with regular cross-school changes, whether there are after-school or other supplemental programs that may draw students enrolled in other schools, whether there are longer versus shorter time spans between random assignment and follow-up data collection, and any differences for post-secondary students or adult learners. So how does the WWC measure individual-level attrition in cluster RCTs? The WWC defines individual-level attrition in a cluster RCT as the number of individuals in an allowable reference sample minus the number in the analytic sample, divided by the number of individuals in the reference sample. We will discuss the appropriate reference sample to use in this step, depending on the risk of bias due to leavers in a moment. The WWC always measures individual-level attrition within clusters that had at least one individual who contributed outcome data, which are called non-attriting clusters. Clusters that did not contribute any outcome data are considered cluster-level attrition. Students in those attriting clusters are not considered individual-level attrition. To calculate differential individual-level attrition in cluster RCTs, the WWC calculates individual-level attrition within non-attriting clusters separately for the intervention and comparison groups, and takes the difference between those two values. As mentioned previously, the risk of bias due to leavers in a study will determine what type of reference sample is allowable to use when measuring individual-level attrition in a cluster RCT. If the risk of bias due to leavers is high, then the cautious attrition boundary is usually appropriate to use when assessing individual-level attrition. And there are two types of allowable reference samples. First are individuals in non-attriting clusters prior to the intervention announcement. The WWC defines this time point as one that occurred before the actors who could plausibly influence individuals' placement into clusters knew the results of random assignment. For instance, a study that randomly assigned schools in summer 2022 could use spring 2022 enrollment counts as the reference sample sizes. A second option for an allowable reference sample are individuals in non-attriting clusters in an early period. As a default, the WWC defines the early period as the first 6 weeks of the school year for intervention implementation. For instance, a study that randomly assigns school in summer 2022 could use early fall 2022 enrollment counts as the reference sample sizes. Review team leadership may decide only allow individuals in non-attriting clusters prior to the intervention announcement as a reference sample if early leaving is deemed to pose a risk of bias. However, if a study has low risk of bias due to leavers, then the optimistic attrition boundary is usually appropriate to use when assessing individual level attrition, and there are 3 types of allowable reference samples. The first 2 are the same as those previously described, and the third option for an allowable reference sample is individuals in non-attriting clusters at follow-up. This reference sample assesses individual level attrition due to missing outcome data without including leavers, capturing whether the analytic sample is representative of the individuals in clusters at follow-up data collection. This late reference sample is acceptable in this scenario because empirically assessing leaving is not needed if the risk of bias due to leavers is low. So, multiple reference samples may be allowable when calculating individual level attrition in cluster RCTs, especially for RCTs with a low risk of bias due to leavers. But in practice, study authors may only report sufficient information to allow calculations for one specific reference sample, thus limiting the options for WWC reviewers. When multiple allowable reference samples are provided by study authors, the WWC will prioritize the one that best aligns with how the study authors defined their sampling of individuals. For instance, if the study authors analyzed joiners and stayers, then the WWC will prefer the third type of reference sample, if it is allowable. But if the study authors analyzed only stayers and excluded joiners, then the WWC will instead prefer the first or second type of reference sample, even if the third type of reference sample is provided and allowable. The WWC also provides additional flexibility for analyses of administrative data, such as district records of student test scores. For cluster RCTs with a low risk of bias due to leavers, the WWC assumes that administrative data have low rates of missing outcome data for individuals in clusters at follow-up, unless review team leadership concludes that patterns of missing administrative data have a high risk of differing across intervention versus comparison groups. In those cases, WWC reviewers do not need to compute individual level attrition rates for RCTs that analyzed administrative data and have a low risk of bias due to leavers. Instead, the WWC will assume the individual level attrition is low for the third type of reference sample. However, for RCTs with a high risk of bias due to leavers, the WWC still will compute individual level attrition using the first or second type of reference sample. In some cases, the analytic sample may include individuals who were not in the reference sample, which poses complications for assessing whether individual level attrition is a concern. The WWC prefers the third type of reference sample in cluster RCTs with low risk of bias due to joiners, if the analysis includes joiners who were not present in the first or second type of reference samples. However, if the third type of reference sample is unallowable or unavailable, the WWC will attempt to calculate individual level attrition excluding such joiners. Another consideration at this step is that there are scenarios where cluster RCTs may exclude some individuals from the sample, but those sample exclusions do not count as individual level attrition, namely sample exclusions based on random subsampling, pre-intervention characteristics, or acts of nature that likely affect both groups equally should not count as individual level attrition. A final consideration at this step in the study review process is for selective or elective enrollment interventions. Studies may assign clusters to receive selective or elective enrollment interventions, such as advanced placement courses, that apply only to a subset of individuals within clusters. In this scenario, the reference sample should generally include all students in the clusters, unless the study applied an exclusion that does not count as attrition. Let's walk through an example to apply what we have learned about calculating individual level attrition in cluster RCTs. A study randomly assigned 10 classrooms to a computer science training intervention and 10 classrooms to the comparison condition. Because the unit of assignment is at the classroom level, the study design has a high risk of bias due to leavers. There were 75 sixth graders in each condition at the time of random assignment in June, and the intervention was announced to teachers and parents in August. The study team reported outcome data from only these students. All of the intervention classrooms contributed outcome data to the analysis. Due to high rates of survey non-response at post-test, the analytic sample included post-test data from only 60 intervention group students and 72 comparison group students. Based on this example, what is the overall individual level attrition rate? What is the differential individual level attrition rate? And does this example yield a low or high individual level attrition rate? Let's first organize the numbers in the example. For the intervention group, we know that there are 20 total clusters, or classrooms, contributing post-test data. We know the risk of bias due to leavers is high. Because the risk of bias due to leavers is high, we assume that the cautious attrition boundary is appropriate to use. So, the allowable reference sample to be used includes the students in non-attriting classrooms prior to the intervention announcement. We know that there were 150 students in this reference sample. We know that 132 students contributed outcome data, absent any joiners. So, we can calculate the overall individual level attrition as 12%. To calculate differential individual level attrition, we take a similar approach but conduct the calculations separately for each group. In the intervention group, we have an individual level attrition rate of 20%, and in the comparison group, we have an individual level attrition rate of 4%. The difference in these two values results in 16 percentage points as the differential individual level attrition rate in this cluster RCT. To determine whether this combination of overall and differential attrition values results in a low or high attrition designation, we take these values and compare them to the attrition table from the handbook. Given the overall attrition rate of 12%, the maximum allowable differential attrition rate is 6.2 percentage points under the cautious boundary and 10.9 percentage points under the optimistic boundary. Recall that the differential attrition rate from our example was 16, which is higher than the 6.2 cautious maximum and higher than the 10.9 optimistic maximum. So, the WWC would consider this to be high attrition under both the cautious and optimistic attrition boundaries. But recall that in this example, the cautious boundary would be used for assessing attrition because there was a high risk of bias due to leavers in the sample. We have now reviewed step 3C in the process for assessing compositional change in cluster-level RCTs. For findings from cluster RCTs that establish low individual level attrition at step 3C, those findings are eligible to be rated meets WWC standards without reservations. But for cluster RCTs that did not establish low individual level attrition at step 3, The review then will proceed to step 3D, where reviewers will assess the third type of compositional change in cluster RCTs, cluster representativeness. This step in the review process provides an alternative route for findings to meet WWC standards when they come from cluster RCTs with low cluster-level attrition, which are unable to collect baseline data but can demonstrate representativeness. In these cases, findings may still receive the research rating meets WWC standards with reservations. Demonstrating representativeness means that missing outcome data rates were low for the population of individuals present in clusters at follow-up. High representativeness is the same as low individual-level attrition when attrition is assessed using the reference sample of individuals in non-attriting clusters at follow-up. It is important to note that the WWC assumes that analyses of administrative data satisfy the representativeness requirement, unless review team leadership concludes that patterns of missing administrative data have a high risk of differing across the intervention and comparison groups. Assessing representativeness differs from the previous step where we calculated individual-level attrition, in that the reference sample is always the individuals in non-attriting clusters at follow-up. Otherwise, the relevant calculations are the same as in the previous step. Similarly, the WWC assumes that analyses of administrative data satisfy the representativeness requirement, unless review team leadership concludes that patterns of missing administrative data have a high risk of differing across the intervention and comparison groups. Knowledge Check 5. In a cluster RCT, 4 classrooms with 88 students were assigned to the intervention group, and 4 classrooms with 96 students were assigned to the comparison group. 1 intervention classroom with 22 students withdrew from the study after random assignment. The analysis of student-level data included 62 intervention and 89 comparison group students, all of whom were present in the study classrooms at the time of random assignment. The study is reviewed under the cautious boundary for attrition, and joiners pose a high risk of bias. How many students would be counted as leaving the study when measuring the overall rate of individual-level attrition? Your response options are A. 0 students, B. 11 students, C. 26 students, or D. 33 students. You may want to pause the video while you think about your answer. The correct answer is B. The original randomly assigned sample included 88 intervention and 96 comparison group students, but 1 intervention cluster with 22 students was lost. Individual-level attrition is calculated only with the remaining non-attriting clusters. So, a total of 11 students were lost who would contribute to the overall rate of individual-level attrition: 4 students in the intervention group and 7 students from the comparison group. Knowledge Check 6. A study examined the effects of a high school dropout prevention program. 4 rural high schools were assigned to the conditions. 2 schools of 300 grade 11 and 12 students were assigned to the intervention condition. 2 schools of 315 grade 11 and 12 students were assigned to the comparison condition. The researchers collected high school graduation outcomes and demographic data from school administrative records. Review team leadership determined that the cautious boundary for cluster-level attrition was most appropriate because intervention status might have an impact on whether schools stayed in the study. What is the appropriate boundary for individual-level attrition in this example? And do leavers pose a risk of bias in this scenario? Your response options are A. The cautious boundary is appropriate and leavers pose a high risk of bias. B. The cautious boundary is appropriate and leavers pose a low risk of bias. C. The optimistic boundary is appropriate and leavers pose a high risk of bias. Or D. the optimistic boundary is appropriate and leavers pose a low risk of bias. You may want to pause the video to think about your answer. The correct answer is A. In this example, schools are the unit of assignment and students are the unit of measurement. However, the dropout prevention program provides benefits or supports that may make some individuals more likely to stay, which could affect leaving. Therefore, the cautious boundary would be most appropriate for assessing individual-level attrition in this cluster RCT, and there is a high risk of bias due to leavers. Note that although this example used administrative data, that is irrelevant in this scenario, given that there was a high risk of bias due to leavers, so we cannot assume there is low individual-level attrition just because the outcome was measured using administrative data. Had the cluster RCT had a low risk of bias due to leavers, then individual-level attrition could have been assumed to be low given the analysis of administrative data. Knowledge Check 7. In a randomized controlled trial, researchers assigned 260 students to the intervention group and 210 students to the comparison group. 21 students withdrew from the study after random assignment. Using the optimistic threshold for attrition, does the study have high or low attrition? Your options are A. High attrition, B. Low attrition, or C. Unclear, not enough information provided. You may want to pause the video while you think about your answer. B is the correct answer. Although it may appear as though there is not enough information to calculate attrition, in scenarios like this, reviewers can opt to examine the worst-case scenario. That is, reviewers can assume that attrition came only from one of the two conditions and calculate attrition under both scenarios. Here, overall attrition is 4.6%. If all the attrition came from the intervention group, differential attrition would be 8.4 percentage points. If all the attrition came from the comparison group, differential attrition would be 10 percentage points. Under the optimistic boundary for attrition, when overall attrition is 4.6%, the maximum acceptable differential attrition is 10.5 percentage points. Therefore, the worst-case scenario of 4.6% overall attrition and 10 percentage points of differential attrition is below the acceptable threshold for the optimistic boundary, and the study has low attrition. This concludes the 6th module in the WWC Group Design Standards training. Let's review what we discussed in this module. We discussed the 3rd step in the WWC review process for group design studies, which is assessing compositional change in RCTs. We showed how to assess compositional change in individual-level RCTs by calculating individual-level sample attrition. And we discussed how to assess compositional change in cluster-level RCTs by assessing cluster-level attrition, individual-level attrition within clusters, and cluster representativeness. Finally, we discussed how these compositional change assessments impact the WWC research ratings that findings are eligible to receive. Remember that you can access all of the resources mentioned in this module on the WWC website, whatworks.ed.gov.